So with this technique I'm about to show you, you'd be able to graph absolutely any math function. So you guys have seen y equals x squared, right? You've seen that one. You know that one. It's like this. And then yesterday we did the domain of that, and that would be like from negative infinity to infinity. My point was, though, that if I show you this new way of graphing that you haven't done before, you don't have to even know what the thing looks like, and you can graph things with this method. So I'm going to show you one that you haven't seen before, and it is x equals y squared. You have never probably graphed this one because it's a little weird looking. So if you wanted to graph this, you could always use the XY chart. It's your best friend in graphing. So take a second and make that XY chart. And then I'll show you. On these charts, you don't have to pick the X's. You can pick the Y's. And you just pick one thing. You like say, I decided I wanted to make Y into 2. You can pick anything you want for either X or Y. Usually you pick X, but in this one, I think it'd be easier if you picked Y. And if you pick Y as 2, can you tell me what X has to be then? 4. So the point 4, comma 2 is on this graph. All right. Let's find another point on this graph. Tell me something else you want to put in. And again, Y would be easier, but if you really want to start with X, you can do that. You just better pick something that you can square to get. So tell me another thing you want to put in. You can pick X or Y. Y is easier. 3 for what? 3 for Y. I like it. So then if you pick 3 for Y, you put in the 3 in your head, and you go 3 squared is 9, so X must be 9. 9 comma 3. 1, 2, 3, 4, 5, 6, 7, 8, 9 comma 1, 2, 3. You know what the easiest thing of all to put in is? 0. You want to put it in for X or Y? I don't care. Pick. If you're not going to pick, I'll pick Y as 0. And then what does X have to be? 0. So 0, 0 is on the graph. Now that looks kind of like the square root graph. And I thought we were doing a squared graph. Well, you haven't seen this one before. Let's put in X is 4. And you might be like, well, we already figured that out. It was 2. What else could it be? If you want this to be 4, what else could you put in besides 2 that would also work? Negative 2. Very good. So 4 comma negative 2. Do you see what this thing is starting to look like? It's kind of like a parabola, but it's sideways. And if this keeps going like this, do you get that 9 would also go with not just 3, but negative 3? It's like a sideways parabola. You've never seen that before, and yet you can graph it. Because why? Because you just find a bunch of points. And once you graphed a bunch of points, you connect the dots. Anybody can connect dots. All right, so you're going to have some problems on your next test, and you're going to be like, oh, I forgot what the absolute value looks like. But it won't matter, because you'll be able to just graph a bunch of points. If you know what the absolute value looks like, would you just raise your hand? I won't promise not to call on you. How many of you remember the absolute value graph? I promise not to call on you, but if you know it, raise your hand. All right. So I'll remind you, the absolute value graph is the one that looks like a V shape. Does that ring a bell from yesterday? Get that I actually wanted you to know that one? All right. I know it was only yesterday, but You got to memorize these. There's 7 of them, including the circle. There was 7. So if I asked you instead to graph this, it's kind of related, but it's that absolute value and it's been moved. But I just told you a second ago, you don't even have to remember that it was an absolute value. Remember how only like 3 of you remembered that it was a V-shape? So if you didn't remember what this was, you'd still be able to graph it because watch how easy it is. You don't have to even do it, just watch for a second. I'm going to put in 5 just because I feel like it. I can put anything I want. 5 minus 4 is 1. Absolute value of 1 is 1. 1 plus 5 is 6. 5 comma 6 is on the graph. If I find enough dots, you'll just be able to connect the dots. What if I decided I wanted to put in 4? I can do that. I put in a 4. 4 minus 4 is 0. Absolute value of 0 is 0. Plus 5 is 5. 4 comma 5. Get the idea? I can put in any number I want. I see what I get. And if you get enough dots, it's super easy to see where the thing is. And you'd go, oh, it's a V shape. I remember this one. Okay. So it really helps, especially if you're not good at memorizing all 7 functions, to be able to go, okay, well, I can find a bunch of points and graph it, and I'll be fine, even if I forgot that it was a V shape. All right, then last thing on this problem, would you please now write this one down, and I will tell you how you can tell where it will move. I know it's a V shape that has been moved right 4 and up 5. The stuff on the inside, I know you're thinking, wait a minute, Mr. Server, are you messing this up? Because it's a minus, and shouldn't that be moving to the left? Because that's where the negative numbers are. And if your instincts say it's left, that's good. Because your instincts should say that minus 4 moves it to the left. But it doesn't, I promise you. When it's on the inside of any kind of grouping symbol, like an absolute value or a parentheses, if it's inside something, then it'll move the opposite way that you think. So this will move right 4, and this plus 5 at the end, that moves the way you would think. Plus seems like up, and it is up. You trust the stuff on the outside, you don't trust the stuff on the inside. All right, there's only one other change that we could expect. My little V shape is going to move right 4 and up 5, but if I put a negative right there, then have you ever heard of a reflection? If you've never heard of that, I'm going to tell you about it today. A reflection in math is where you take a graph that used to be a right side up V shape, and now it flips upside down and becomes an upside down like a mountain shape. Okay, so like this graph here, if I just stick a negative in front of the graph, it makes all the y values be the opposite of what they were, and that's called a reflection. Okay, so the last thing about that is, on the reflections, we have to have you know which direction it reflects. It's either a vertical reflect, which is what I just did, the up and down kind, or if it's not a vertical reflect, it could be a horizontal reflection. Let me show you what that would look like. If I put the negative on the inside, then what happens to your V shape is it flips this way. But the weird thing is, it ends up landing right on top of where it used to be, and so it's like it never happened. Now, I think it actually makes sense. Think about it. Aren't absolute values such that if you put a negative on the inside of them, it's not going to matter because the absolute value will knock the negative right off of it? Like, doesn't the answer always come out positive? See what I mean? So putting a negative in there shouldn't do anything. And it doesn't. It makes the graph flip this way, but it goes right back on top of itself, and so it's like it never happened. Okay, so that was a lot. Let's see if you can pull this all together. Imagine I gave you this one. Y equals, please write this one down. Square root of x minus 7. On the outside of the square root, we're going to put minus 2. I know from memory that this thing looked like a square root graph looked like this. But lucky for you, even if you forgot that, you could make an XY chart, graph a bunch of dots, and guess what? They'd end up here and here and here, and you'd be like, oh, I guess that's where the graph is. So you don't even have to memorize them if you want to take the time to graph them. But this thing has been moved. What's that? Over what? Don't say over, say right or left. What do you think it is? Right. How far? 7. The whole graph will be moved right 7. Now you can imagine if I could grab this with my hand and I just go drag it over that way, 7 spots. Okay. And what would this thing do? It would move it where? Down 2. Very good. You catching on to what those mean now? On the inside, it's horizontal on the inside, high. On the outside, it's vo. That is a very powerful, super short little mnemonic. Horizontal inside, vertical outside. Because if we said, oh, but Mr. Server, there's also a negative here, and that means it reflected, and if all you say is reflect, your answers, if you had just written this on a test, I'd have to mark it wrong because you didn't say what kind of reflection it was. You got to tell me if it's vertical or horizontal, and it's vertical if it's on the outside. Does that negative look like it's on the outside? It is on the outside, so that's a vertical reflect. Okay, so you got horizontal on the inside, you got vertical on the outside. That's one thing you got to know from now on. We're going to use this probably 75 times between now and the end of the year. I'm telling you, this is one of those topics. I say this a lot, but it's true. At the beginning, we're teaching you all the really important stuff we use all year. So where you move functions just keeps coming over and over. Because like so far you've got like these 7 functions. We're going to talk about more things like what a log is. And you'll learn what a log graph looks like. And then we'll be like, oh, but we're putting a number on the inside. So it's going to move it to the right or left. And if we put something on the outside of the log, it'll move it up or down. These work for like all functions. All right. So to make sure you really got this now, here's one that we haven't talked about yet. It's the x to the 3rd function. I know you might have forgot how it looks, but it wouldn't matter as long as you can stick numbers in and graph it. But if the only question was, Mr. Server, put a +1 here and a -3 there, and that's good enough. Just can tell the kid next to you, what does that do and what does that do? Talk about it.
I just remember the high one.
It seems like it's right one. It's not right one. Left 1 and down 3. I know you're just learning this, but how many of you guys had it exactly right? Raise your hand if you had it exactly right. How about half of you? All right. Process that, and we need to do another one then, if only half of you got it right. I know it seems like that should be to the right one. I get it, but it's the opposite of what you would think when it's on the inside. It's counterintuitive, and that's always hard. There is actually somebody who hooked up a bike where when you turn the handlebars on the bike to the left, it goes to the right. And it is so hard to like break your patterns of, you expect intuitively, you turn the wheel to the right, you're going to go to the right. But this bike does the opposite of that, and it really messes with your head. And that's what these do. This should feel like it's right, but it isn't, it's left. This should feel like it's down, and it is down. We can trust the stuff on the outside. All right, here's one more. Y equals -√x minus 1 plus 4. 3 things have happened. Remember, if you do say the word reflect, you got to say which kind of reflect it is. Talk to the kid next to you, see what you think. This is the only new thing for today. Right 1, up 4. If you just said reflect, you got so close. Vertical reflect. Remember, it's high vo, horizontal if it's on the inside, vertical if it's on the outside. Okay. Cool. Now, if I had to graph it, I would pick nice, easy numbers and stick them in. And you might think, well, 0's an easy number, but when you put in 0, do you right away have square root of -1, which doesn't even exist? It's not real. It's imaginary. So then you can just put a line like this. If there is no point there, I just put a line like that. Now I'm going to put another point that would be probably better. How about 1? Because if I put a 1 right here, do you get all of a sudden I now have square root of 0? And that's not illegal. What's the square root of 0? 0. And then add the 4. And I get 0 plus 4 is 4. 1 comma 4. That's 1 point on this graph. Do you get, well, graphing 1 point is not going to do it for you on the test. You're probably going to have at least 3 points, okay, to be able to see where to connect the dots. So let's get one more. If I put in 3, would it work nicely? Square root of 2? I don't have the square root of 2 memorized, so that's not going to work real nice. So don't pick that. I mean, it's not illegal, but who wants to figure out the square root of 2 in the middle of a test? So what would work nice? 5 would work nice. Because if I put in 5, I get square root of 4, which is 2, plus the 4 makes 6. I put in a 5, and I got 2 plus the 4 makes 6. 5 comma 6. See what I'm doing there? Is that enough points? 2 points can tell you where a straight line goes, but 2 points cannot tell you where a curving line goes. Pretty much all your functions are, well, there's one that's a straight line, but the rest of them are all curves. So you'll need at least 3 points. So talk to your partner about one more thing you could stick in there. Hint, 9 does not work. Everybody stick in 10, see what happens. Now, I have been acting like there is no negative in front, and I probably shouldn't have done that. There is a negative in front. I'm going to erase it now. You wouldn't have one this hard today, so I was acting like there was no negative. So let's just erase that negative off of there. And then I suggest you stick in 10, and so let's do that. We put in 10, so then this is going to be a 10 right here. And then you get the square root of 9, which is 3, plus 4 is 7. Who had 7? Awesome. See, if you graph these 3 points and you connect the dots, you'd have a curve. All right, cool. And it would look generally, this is what I tried to teach you yesterday, but you guys' memories weren't amazing. That was what the square root looked like. And then generally it's been moved right 1 and up 4. So if I zoom in on this and I go, how do I move it right 1? Well, I just move it over 1 and then up 4, and then that would be about there. Do you get how the whole thing moved right 1 and up 4? And if you graph those points, these 3 points, they would be exactly right on that line, which moved right 1 and up 4. The negative that I was throwing in was a little stretcher. Like, we're not actually doing those today yet. We're not reflecting them also. Reflections come in a couple days. All right. So let's actually do the first problem of your homework together. So everybody, please find the homework. It is a worksheet. And I want to make it more reasonably sized. You'll find, I'm pretty reasonable on homework. I don't want you to have too much homework, because then you'll start avoiding it. I want you to have it be small enough that you're like, that's not bad at all. I can do that. So for tonight, your assignment is to do the prime number problems. Now, I know you may have forgotten the primes, but this is my sneaky way of throwing that in so that you remember them. Somebody name a prime that you are confident is a prime. 3 is definitely a prime. You are correct. So you'd have to do number 3. Can anybody name another one that is definitely prime?
11.
11 is definitely prime. Yes.
7.
7 is definitely prime. Are you noticing that these prime numbers are all things that you can't find a way to multiply to get them? The official name for, or the reason that they're called prime numbers have exactly 2 factors. 1 and themselves. That's why 1 is not a prime, because 1 only has one factor. A lot of people think 1 is prime. Promise you, if you look it up, you'll find out 1 is not prime, because a prime number has to have exactly 2 factors, and 1 has only one factor. So 1 is not prime. So you don't have to do number 1. How about 2? Is 2 prime? I know you're like, but it's even. Well, how many factors does it have? 2 factors. 1 times 2 makes 2. Those are the only factors there is, so 2 is prime. So you have to do number 2. Talk with your partner about, to start with, just agree on what the primes are. Okay, you've got somebody sitting right next to you. Behind you, or people in front of you.
We got 2, 3. What? Wait, what did you get to?
5 and 7.
Okay, and then we have 11.
Okay. I hope you came up with 2, 3, 5, not 6, because there's too many factors. 7 is prime. How about 9? That's a classic. Not a prime, because you can do 3 is also a factor of 9. So, and then I think, is 13 still on your sheet? Is there a 13? Okay, there you go. So there's the ones you have to do. So let's do number 2 together. Would you please read me number 2? Would you read me that? F of x equals?
The square root of x minus 4.
All right, and I think all we have to do is graph it and then say the domain and range of it, right?
Yeah.
Okay, so if I had to graph this, if I had memorized exactly what all the points of a square root are, and I knew that, I could just move them all up 4. But, in my opinion, it's actually easier to just make an XY chart, find 3 points, and graph them. So tell me, what's one point that would, or X number, that would work real nice? 9 works real nice, I agree. Because now the square root of 9 is 3, and then 3 minus the 4 makes -1. So 9, -1. Over 9, down 1. What's something else that's real nice to put into a square root? 4. Square root of 4 is 2, and then don't forget the -4. So I've got square root of 4 is 2, 2 minus 4, -2. 4 comma -2. And is there any other points that would work nice? Jack Breen, give me a point.
16 would
16 is too, exactly, so that's probably too big. Think small numbers. Square roots of small numbers work nice. 1 works. Square root of 1 is 1. 1 minus 4, -3. All right. And I made my little boxes are so small that mine is barely curving at all. But if I made my boxes bigger like this, I think it'd be easier to see what this looks like. There you go. It's that ramp shape. Okay, cool. Now how about domain and range? Ooh, that's right. Domain, that's how far left to how far right. It doesn't go forever to the left. It starts right here. How far to the left is that? 1. Remember, these are X numbers. Domain is about X. I'm going to put a little X inside the D. The domain is about X. And it goes from 1 to, does it ever stop going to the right? So it's inf. 1 to inf. But, little side note, it's wrong. Does anybody know why?
Couldn't you have
Wait. First of all, it is 1. To start with here, unless you might be right in a second. There's a bracket. I heard the people say bracket, and that's what I was looking for. But, wait a minute. You might be right. This whole thing is moved down 4, and doesn't it start at 0, 0? Crap, he's right. It should have been able to put in a 0, you know, like we could have put in a 0, and then we would have had a 0 and a -4, and you're right, there should have been a point right there. So I actually had my range messed up because I didn't graph enough points. Moral of the story, graph as many points as you can. And I could actually graph this one, like there's one there and there. I think that we can graph 4 points, and then we'd have enough to be able to see, it actually goes from 0 to infinity. And if you think about the actual graph, like look at it, isn't the lowest number we can use 0? Yeah, I thought it was 1 for a second there. But thanks for catching me. Good job. So domain, 0 to infinity. All right, so don't just think, well, I can look up the domains from yesterday. The domains can change. Like the range is going to change on this. Well, actually, no. Moving it down doesn't mean, it still goes up forever when you do the range. But sometimes when you put in different numbers, your domain and range of your graph will change. Okay, so now let's do range. Range, it will really help to look at it. What's the lowest it goes? -4. And that's, like, that did change. The old range would have been, for the original graph would have been up here. The old range would have been 0 to infinity. This is -4 is the lowest it goes to infinity. All right. Hey, you signed up for an honors class. It's not all going to be walk in the park easy. So, at least you got a much smaller assignment today. Just a few, just those prime numbers. Now that quiz, how many groups are done with the silver 20? Raise your hand if your group is done. All right. Is there any groups that are not done? You need another minute. All right. And I will give you another literally 2 minutes, and then I'm going to tell you the answers. You're going to grade it at your own seat. So I think I'm going to stop the video there because the only other thing I'm going to do is read off the answers, and I'll post those for the silver 20. And then we're going to hit Dropbox that at the end of the hour.